There you go. Right.
Yay.
Still didn't start.
There we go.
Okay, what is one simulation, Ava?
A dice.
A dice. Okay, so if you used a die, how would you do it? How would you do 1/3 with a die?
Oh, 1 and 2 is 1, and then 3 and 4 is 2, and 5 and 6 is 3.
Okay, so what would 1 and 2 represent in this situation?
1.
Well, what are we looking to find out
I don't
through
know.
our through our Alpine Zoom? Jack?
We gotta figure out if it's gonna snow or not.
If it's going to snow or not. So 1 and 2 would represent snow or no snow?
No.
Yes, no.
No snow?
Okay, well, I would be done.
And then 3 or 4 would represent what?
Yes, no.
No snow. And 5 and 6 would represent
No.
snow. Good. So we have 1/3 representing snow, 2/3 representing no snow. How many times would we have to roll the dice for trial?
4.
6.
Connor? 10. Why 10?
Because it's 10 days.
There's 10 days. So we have to roll the die once for each day. What else could we use for a simulation other than dice? Andrew?
A spinner.
Okay. What would our spinner look like?
1, 2, and 3. Cut into the third.
Okay, so it would be cut into equal thirds. And how many of those thirds would represent snow? How many no snow?
2 would represent no snow. 1 would represent snow.
1/3 snow. And how many times would we have to spin the spinner?
10.
10 spins per trial. So if we want to do multiple trials, we're going to have to do it maybe 40, 50 times to get 50 weeks worth. Okay, anything else we could use as a simulation?
Paper.
Paper, okay. What could we do with paper?
Put it in a bag.
Put it in.
Okay, paper in a bag, and what will we write on the papers, and how many would there be?
No snow, no snow, and snow.
Okay, so we could just have 3 papers, no snow, no snow, and snow, and how many times will we have to draw from the bag?
10.
10 draws.
Okay.
Okay, does anybody else have any other ideas for simulations you could do for this?
I don't know any other, like,
Here's another one that you probably haven't thought of, but I thought of because I was preparing an earlier lesson that we didn't do from this unit, is you could put colored blocks in a bag rather than writing letters. So you could say that maybe white blocks represented snow and green represented no snow, because that would be grass. It really does. It's really the same thing. So you can get creative and use different things. All right, so I'm going to come around and give you what you need for your simulations, and then we'll be talking about it later. Okay, so first I'm going to show you the simulation that I have done up here. So I used N for no snow, S for snow. You guys may have kept track differently. So we're looking for the probability that what has to happen. What do I have to get a yes?
4. 4.
4. Just exactly 4? Does it have to be exactly 4?
No.
What does it have to be?
4 above.
4 or above. It said at least 4, so that means 4 or more. So in 3 out of my 5 cases, I had 4 days, at least 4 days that had snow. So my probability based on what I have up here would be what? Raise your hand. Chris?
3 out of 5.
3 out of 5. What kinds of probabilities did some of you get? What did your group get, Katie? You also got 3 out of 5, so we have another 3 out of 5. What did you guys get? 2 out of 5.
What did I get? 40%.
What did you get?
4 out of 5.
4 out of 5. Wow. You guys had a lucky week. Yes. Also a 4 out of 5. And you guys?
2 out of 5.
2 out of 5. And what else?
2 out of 5.
2 out of 5. Okay, so if we were to look at all of our probabilities put together, we could actually estimate the probability based on our whole class. So we had each 5 trials individually, right? But as a whole class, including me, we had 1, 2, 3, 4, 5, 6, 7. We had 35 trials. How many of those trials resulted in snow?
Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Allie?
Is it 20?
Let me see.
21.
Let's see, let's add it up. So 3 here, plus 3 here is 6, 8, 11, 15, wait, 6, 8, 12, 16, 18, 20. All right, so 20. 20 out of 35. Let's see what that would be. Guys, no talking.
4, 7.
Okay, so let's see what that would be. 20 out of 35. What percent is that?
57.
So we got a 57% chance. So we got a much higher chance than some of us got individually. Because here, what's a 3 out of 5? How many is that?
60.
60%. So these people had 60%. 2 out of 5 is what?
40.
40%. 4 out of 5 is
80.
80%. Why might it be better to use the whole class's data than individual data? What about the whole class data makes it better? Ava?
Because it's out of 5, so it, I don't know. There's more data, so you should be able to answer more stuff.
All right, there's more data. So anytime we increase the number of trials, we get better results. How much was the theoretical probability of it snowing?
What's that mean?
Like what percent, based on how you set up your simulation, was the probability of snowing? Like if you made a spinner, what part of the spinner represented snow? Katie? 33%. It was 1/3, which would be 33%. So in reality, we ended up getting a much higher number, which is kind of an interesting result because I would expect to get something closer to 33%. And probably if we did this trial hundreds of times, we probably would get closer to that 33%. All right, let's talk a little bit about Kieran's game. How many of you won the game at least once?
Be quiet.
Okay, so we have 1, 2, 3, 4, 5, 6, 7 people who won, and probably about the same amount who did not.
I lost.
Now, how many times did you have to play before you won?
1, 2, 1 turn. When you left, I got
I won.
0 times.
So if you were to use, let's see if we can figure this out. How many times do you guys think you played all together?
2.
No, just wait, just this group.
6.
6 times, and you won how many?
Twice.
Twice. So that group was 2 out of 6. Okay, what about your group? 1 out of 4. Okay, go ahead and go to break. We'll talk about this when it's over.
I'm gonna go slow.
Let's go to the back group. How many times did you guys play the game collectively between the two of you? 4, and how many times did you win?
I won 3.
You won 3 times?
No, you didn't. No. We
Oh.
won 3 altogether.
You won 3.
Oh, I thought you meant.
Wait,
like
so you played how many times?
4.
4, and you won 3 out of the 4.
Yeah.
Okay? Okay, how about you guys?
Oh.
You played 2, you won both times. So you got across in 5 rolls. Only 5 rolls, okay? Okay, how about you two? You played 6 and won how many? 3. So you played 6 times, you won 3 times?
And the last one was a tie.
Okay, how about you guys in the back? What was your? You played twice? Like together, you all played twice, so that was 6 times total? Okay, and how many times? How many wins were there out of the 6?
1.
1 win? Okay, your results are actually more typical. The chances of winning this game
Did you guys say you played twice?
are closer to, I believe the chances were 1/6. It's a lot closer to the people who got lower amounts. It's actually kind of difficult to win. When I played 6 times and I won once. So I had a probability of 1/6. Sometimes when people play this, they'll get a probability of 0 out of 6 because they won't win at all. Let's talk about the questions a little bit. If we were to change the rules so that the playing piece must move 7 spaces within 8 moves, how would that affect the probability of winning the game? Ava?
It'd be harder,
It would be harder. Why?
because the probability of winning is lower,
Yeah, what would make it lower?
7 or 8.
7 over 8?
Yeah.
The probability is not necessarily 7 over 8. You have to move 7 spaces in 8 moves. So you have to get the right thing to move 7 times, right, out of the 8. You can only miss once, so you can only miss 1 out of 8 times. So the probability would actually be 1/8. What if we changed the board so all the spaces were black? How would that improve the probability of winning the game? We've still got the white and black blocks in the bag, but now all of the spaces are black. Chris?
It will make it greater.
How? Katie, what do you think?
I don't think it would change,
Yeah, Katie's right. It wouldn't change. Why, Katie?
because then you still have a 50-50 chance of getting the right color.
Yeah. So even if they were all black, you still have a 50-50 chance each time of getting the right color, so it really doesn't make a difference. What would happen if we changed the blocks in the bag to 3 black blocks and 1 white block? Would it be easier or harder to win?
Harder.
Harder? Why do you think it would be harder?
I didn't even hear the question, I was just guessing.
If you change the blocks in the bag to 3 black blocks and 1 white block. Katie, what do you think?
I think it would also be the same, because it's easier to win on the black ones, but then it's
Yeah, so maybe out of the 2. I think it might be slightly harder because I think the chance of getting that white one would be so low that you'd be more likely to miss, but either the same or slightly more. All right, last thing that we are going to do is, all right, so we're going to be matching each of these situations to one of the simulations. Emily, with what simulation did you match situation A?
Number 2.
Number 2, okay, good. That is correct. So number 2 tells us that we're going to make a spinner with 4 equal sections labeled 1, 2, 3, and 4. Spin the spinner 5 times and record the outcomes. Repeat this process many times and find the proportion of the situation in which a 4 appears 3 or more times to estimate the probability. Okay? Why do we need to spin the spinner 5 times? Bryce?
Because then you need to get the active, because it tells you to.
Where does it tell you? Where does it tell you to? What in A tells you that you're going to need to spin the spinner 5 times in number
Because it
2?
says repeat the process 5 times in the first leg one.
Okay, good. So you're getting a fish, repeating it 5 times. So this repeating the process 5 times goes with spinning the spinner 5 times.
Yes.
Okay, why does the number need to show up 3 or more times?
What?
Jack? Why on this does it say that a 4 has to appear 3 or more times?
Because,
What situation are we trying to simulate? What do we want to happen?
to get the fish,
What might the 4 represent from here? What would
how
the
many
4
fish
represent?
are female?
How many fish are female? Good. So here it says that 25% of the fish are female, so we can only have 20% of our possibilities being female. And so if we just use one of the sections, we've got 4 sections, if we only use one of them to be the female fish, then we have accomplished that percentage. Okay, questions about this? Okay, let's take a look at the next one. Ellie, what did you put for B?
I put it with 4.
With 4, good.
I did that too.
Good, B does go with number 4. Does anybody have any questions as to why B goes with number 4?
I just saw the 8 and the 80.
Okay, so the 80%, but how does the 8 go with the 80%?
I don't know, I didn't read it.
Okay, the 8 doesn't go with the 80%. What about this gives us the 80%? Emily?
Because the 8 boom chips and cinnamon chips out of 10, and the 8 out of 10 of them are really
Excellent, I'm
So
just
it
gonna
does have
repeat that,
something to
because I
do
don't
with
know
80%.
if you recorded it, so, I mean, if it picked up what you were saying. So if we have 8 blue chips and 2 red chips, that's 10 chips altogether. 8 out of 10 would be 80%. So a blue chip would represent the chance that Alina would make the free throw.
So the 8 and the 80 do go together.
They do, but I needed to know, the 8 by itself doesn't mean 80%. The 8 only means 80% because it's out of 10. So you have to give both in order to get a percentage.
Ah, so I was
All right, next one.
right.
Ava, what did you get to go with C?
1.
Number 1, good. What about number 1 made you think that it would go with C?
Do you really want to hear my reasoning?
Maybe not. Tell me, rethink your reasoning. If it was just kind of some random thing, rethink it so that it makes sense.
Let me read it first.
Does anybody else want to explain it?
Fantastic.
What about number 1 makes it go with C?
Well, there's 3 doors.
3 doors, but a dice has 6 sides, so how
Yeah.
does that go?
And there's 1 and 2. I don't know. I think they were just my last options, and I put them together.
Okay, does anyone want to explain that? How, if a dice has 6 sides, it has 6 possibilities, and this has 3 possibilities, how can we use a dice to represent that then? Jack?
Well, you can use 2 of the numbers to represent one of the things.
Good, we can use, it's a multiple of 3. 6 is a multiple of 3, so we can use every 2 numbers, yes.
What is a standard number?
It's a 6-sided dice.
Can't they just say
Standard
a
number
dice like
cube
you have?
means a dice. Well, no, because there are dice with other sides too, so when they say standard, it means 6
Well,
sides.
we don't
Well, they
know.
could just say 6.
All right, our last one, D, obviously has to go with number 3 because that's all we have left. Why would we use a coin for this simulation? What about it tells us to use a coin? Ava?
Because it's a 50-50 chance.
It's a 50-50 chance and a coin has 50-50, or has also a 50-50 chance. All right, let's sum up what we've done today. So did you learn? We're going to talk about this, and this is not on your paper. This is just something, you are going to take an exit ticket today, and this will kind of help you get ready for that. So Karen used a simulation to determine whether it would rain at least 2 days in a week. She knows that the chance of rain is 1 out of 4. What could she use for her simulation? So what could Karen possibly use to do a simulation of rain? Andrew?
I should use a die.
Okay, how would you use a die?
Just use 4 sides, like 1, 2, 3, 4, and then skip 5.
Ignore 5 and 6.
Okay, so we would ignore. It's kind of better to use things where we don't have to ignore something because then there's also that it changes the chance. What's that?
A spinner.
A spinner. You could use a spinner, and how many sections would the spinner be divided into?
2, 4. You can do
Okay,
1
okay. So if it was divided into 2 sections, let me ask you this: how big would each section be?
One would be 3/4 and one would be
Good, good. So you could divide it into 2 parts as long as one of the parts is 3/4, the other is 1/4.
Or
All right.
4.
So Karen did the simulation. She maybe used a spinner, maybe used papers in a bag, something like that. And these are the results that she got. So for week 1, she did it 7 times because there are 7 days in a week, and she got rain, no rain, rain, no rain, no rain, no rain, no rain. What should she estimate as the probability that it will rain at least 2 days in a week? I want everyone to think about this. What should she estimate as the probability that it will rain at least 2 days in a week? Okay, no hands yet, because I want everybody to have lots of think time. And just one question.
big.
No, and answer.
Okay, I'm not ready for the answer. Put your hand
Well,
up.
you put my hand up. Is this desk tie-dye?
Chris, what do you think?
I don't know.
Well, let me ask you this, Chris. Did it rain at least 2 days in this week?
Yes.
Did it rain at least 2 days in this week?
Yes.
How about this one?
Yes.
How about this one?
No.
How about this one?
Yes.
How about this one?
No.
So in how many weeks did it rain at least 2 days?
4 out of 6.
4 out of 6. So that would be a good estimate of the probability that it would rain at least
Oh, that's gonna do 2 out of 7.
Okay, if you go to the summary on the back, it also kind of summarizes the lesson in a different way, so you can read through that. Especially if you're watching the video and you were absent, that might be helpful for you.